Your heart is an absolute powerhouse. Did you know it creates enough energy in a single day to drive a truck for 20 miles? That's right, your heart, pumping quietly away in your chest right now, is a biological engine more efficient than most machines we've ever built. But how does it manage to do that? And what does this say about the human body's extraordinary capabilities? Stay with me, because what you're about to learn might just change the way you think about your own heartbeat. Think about this. Over the course of an average lifetime, your heart beats more than 3 billion times. That's a number so huge it's hard to wrap your head around. But it's not just about the sheer volume of work, it's about the force and energy behind it. This small, fist-sized organ, weighing less than a pound, is constantly working. Even while you're sleeping, it's pumping blood, delivering oxygen and nutrients to every corner of your body, and keeping you alive without you even noticing. But here's the thing. What if I told you that scientists have calculated the energy your heart generates in a day? And not just that, it's enough to power a machine. A truck, in fact, for an entire 20-mile journey. Incredible, right? In this video, we're going to break down how your heart achieves this, why it's so efficient, and what this means for the future of science and technology. And we'll even dive into how some researchers are looking at the heart as a source of inspiration for energy solutions. So let's dig in. Here's something that'll make you stop and think. Machines break down, batteries lose charge, engines wear out over time. Yet your heart, the most vital engine in your body, runs non-stop from the moment you're born until the day you die. No maintenance. No replacements. Just constant, unyielding performance. But there's a catch. For all its brilliance, the human heart is not invincible. Cardiovascular diseases are one of the leading causes of death worldwide, affecting millions of people every year. Despite being such an efficient, reliable organ, the heart is still vulnerable to the effects of our lifestyle choices, genetics, and age. So, here's the challenge. How do we keep this energy powerhouse running smoothly for as long as possible? And here's another question. Could the heart's incredible efficiency inspire us to create more sustainable technology? Scientists are already studying its mechanisms to develop energy solutions that mimic nature's brilliance. What can we learn from this tiny biological marvel that powers everything we do? Let's start by breaking down how your heart works. At its core, the heart is a muscle, divided into 4 chambers: the left atrium, left ventricle, and right ventricle. Blood enters through the atria, gets pumped into the ventricles, and then it's off to the lungs or the rest of your body. Simple enough, right? Not so fast. The heart's real magic lies in its rhythm, a steady electrical signal that controls the contraction and relaxation of those chambers. This rhythm ensures that blood is pumped efficiently, delivering oxygen and nutrients to the body's 37 trillion cells. Every contraction generates pressure, which creates the energy needed to push blood through over 60,000 miles of blood vessels. Now, let's talk energy. On average, the human heart pumps about 2,000 gallons of blood each day. That's enough to fill a large swimming pool every week. And to do that, it produces around 1.5 watts of power per second. Over 24 hours, that adds up to enough energy to move a truck 20 miles. This isn't just a fun fact, it's a mind-blowing testament to how efficient and powerful your heart really is. But how does it stay so efficient? The key lies in its design. The heart's walls are made of a special type of muscle tissue called cardiac muscle. Unlike the skeletal muscles in your arms or legs, cardiac muscle cells are packed with mitochondria, the power plants of cells. These mitochondria produce ATP, the energy currency of the body, allowing your heart to keep beating without tiring. And here's where things get even more interesting. Your heart doesn't work in isolation. It's part of a system so intricate, so fine-tuned, that it can adapt to your body's needs in real time. During exercise, your heart rate increases, pumping more blood to deliver oxygen to your muscles. When you're resting, it slows down to conserve energy. It's like a biological smart engine, constantly adjusting to keep you alive. Let's zoom out for a moment. What does this mean for the future of technology? Scientists are fascinated by the heart's energy efficiency and durability, and they're working on ways to replicate its design in artificial systems. For example, researchers are studying the heart's pumping mechanism to develop energy-efficient water pumps and hydraulic systems. Others are looking at its electrical signaling to improve pacemakers and other medical devices. And then there's the idea of harnessing the body's own energy to power wearable technology. Imagine a world where your smartwatch is powered not by a battery, but by the electrical signals of your own heart. This concept, called bioenergy harvesting, is already in the works. Scientists are exploring ways to convert the mechanical energy of your heartbeat into electricity, creating self-sustaining devices that never need charging. But the implications go even further. By studying the heart, we're also learning more about sustainability. How can we design machines that run continuously without breaking down? How can we create systems that adapt to changing conditions, just like the heart does? The answers to these questions could revolutionize fields from medicine to engineering to renewable energy. So, what have we learned? Your heart isn't just a vital organ, it's a masterpiece of biological engineering. It generates enough energy to power a truck, beats over 3 billion times in a lifetime, and operates with an efficiency that most machines can only dream of. But it's also a reminder of how interconnected we are with the natural world. The same principles that make your heart so powerful, efficiency, adaptability, and durability, are the principles we need to embrace as we look for solutions to some of humanity's biggest challenges. Take a moment to appreciate what's happening inside your chest right now. Every beat is a testament to the incredible design of the human body, and a source of inspiration for what we can achieve when we look to nature for answers.